Assalamu alaikum everyone. I hope you all are doing well. This is your instructor Ali Faruqi and you are watching Science with Ali. So today we have a very simple topic from O level and IGCSE chemistry, which is redox reactions. So when I talk about redox reactions, it is a very simple type of reaction. So I hope you all know that what is neutralization and what is combustion. A neutralization reaction is when an acid and an alkali react to produce a salt and water. Like this, a combustion is a reaction in which a substance burns in oxygen to produce carbon dioxide and water. So how can you distinguish how a combustion reaction and a neutralization reaction the difference between them? How can you distinguish that? You can do this by identifying the things that are happening. For example, in a combustion reaction, you will know that one of the reactants is going to be oxygen, and the product is going to be carbon dioxide and water. And in a neutralization reaction, you can confirm that an acid and alkali react to produce salt and water. So, like this, there's another type of reaction called redox reactions. So, redox is basically a word that has two types of. It is divided into two parts. It's called red and ox. So, the red stands for reduction, and by all means this does not mean that the quantity of the substance is decreasing. I will get to this in a minute. And the ox stands for oxidation. So let me just write it down over here, that this does not mean that the quantity of the substance is decreasing. Does not mean quantity. So they are both processes, and we can say that we have fused them as one terminology. Instead of just calling them reduction and oxidation separately, we have just turned them as a redox reaction. So why have we called them as a redox reaction? Because they are both processes, and we can fuse them as one terminology because they always happen together at the same time. Redox reaction is a reaction in which reduction and oxidation takes place simultaneously. In the reaction, at one instant there will be a reduction going on, and in one instant there will going to be oxidation going on. So let's look at the types of reduction and oxidations. I hope this makes sense. Let's look at it deeper at what oxidation and reduction is. So there are these types of oxidations and reductions in redox reactions. So as you can see here, I have written down some fair comparisons between oxidation and reduction. You can see that whatever is written in oxidation, it is exactly the opposite of what is written in reduction. So what we can conclude in this is that redox reactions are simultaneous and completely opposite of what's happening of them. Okay, like for example, if in oxidation there's a gain of oxygen going on, so in reduction it's going to be a loss of oxygen. In oxidation, if there is a loss of hydrogen going on, so in reduction it's going to be a gain of hydrogen. You can see that they are completely opposite of each other, like I've stated over here. So when will a reaction be redox? We need to understand and evaluate these two types of properties over right here right now. So when will a reaction be redox? A reaction will be redox if one of these four things is happening, or all of them are happening at the same time. Like it can either be 1, 2, 3, or even all four of them can happen at the same time. So then we can call it a redox reaction. Are we good? So let's work with a few examples to solidify this concept more clearly. Let's assume that a reaction looks something like this. Zinc plus copper oxide gives us zinc oxide and copper. Now I will have to write down one more thing as well. So reduction was loss of oxygen, and oxidation was gain of oxygen. All right. So what we need to identify in this reaction is that which element in this reaction gains oxygen. So which element is gaining oxygen and which element is losing oxygen. So we can clearly see that over here on the reactant side, zinc was without oxygen, and over here on the product side we can see that zinc has made a bond with oxygen. And on the other hand, we can see that copper oxide on the reactant side is bonded with oxygen previously, and after the reaction has taken place, it has lost its oxygen. So we can conclude that zinc has gained oxygen and copper has lost oxygen. So what we can conclude is that zinc has been oxidized and copper has been reduced, because copper in this reaction loses the oxygen, so it's reduction, and zinc on the other hand gains oxygen, so it's oxidation. Okay, so let's move on to another reaction. So the next reaction I have over here is iron 2 oxide reacts with carbon monoxide to give us iron and carbon dioxide. You don't need to worry about the balancing over here. The balancing has been taken care of over here. So you just need to worry about which element is being oxidized and which element is being reduced. I hope I've made myself clear. So what's happening over here? I'll just give you 2 minutes. You can pause the video. So now, which element is being reduced and which element is being oxidized? Which element is gaining oxygen and which element is losing oxygen, right? So we can clearly see that on the reactant side, I would suggest that you isolate one of the reactants and look at the corresponding product on the product side. For example, over here we can see that there's, if I look at iron for just a second, there I have iron over here and I have iron over here. I can clearly see that on the reactant side, iron has made a bond with oxygen and iron has lost that bond on the product side. So I can say that iron loses the oxygen. So iron Fe loses oxygen. So now that the iron is taken care of, we can now focus on the carbon monoxide. Because there is only one oxygen over here, and there's 2 oxygen over here bonded with carbon. You can see this is the carbon and this is the carbon, right? So this is the carbon and this is the carbon. Okay, so I can clearly see that there's only 1 oxygen over here and there's 2 oxygens over here. So I will conclude that carbon gains oxygen. Okay, so we can conclude that Fe, because it loses oxygen, it is being reduced, and because the carbon gains oxygen, it is being oxidized. Clear? So now that the first part of our table has been completed, we can now move on to the second part, which is this. The next two, the electron part and the oxidation state part, is going to be in the next video, so stay tuned for that. Up till now we have done the gain of oxygen and the loss of oxygen, so that's completed. Now let's move on to the oxidation and reduction involving hydrogen. So in oxidation, what happens is that the element loses hydrogen, and in reduction the element gains hydrogen. So let's implement that over here. I have a reaction over here as well. So let's start with 2NH3 plus 3Br2, which gives us nitrogen plus 6HBr. Like I've said, you do not need to worry about the balancing. This is just a very easy, simple equation. You just need to worry about which is gaining and which is losing hydrogen, right? So you can pause the video right now and see which element is losing and gaining hydrogen. I would recommend that as I told you earlier, isolate one of the elements on the reactant side and isolate one of the elements on the product side. So you can pause the video right now. Okay, so I'll go ahead and solve it. Let's move on. So I can clearly see that nitrogen has been bonded with hydrogen over here on the reactant side, and nitrogen has lost that bond on the product side. So this has got to be something. Okay, so I can clearly see that nitrogen has lost hydrogen, right? So the loss of hydrogen is oxidation. I have written it up there. So I can say that N2 it has been oxidized. Now that's taken care of. I think that leaves the last part very easy for to solve. So the Br2, it is without hydrogen on the reactant side, and on the product side it includes hydrogen over here. You can see that. So I can now say that this has bromine has been reduced. Okay, so because there is oxidation and reduction happening simultaneously, one element is being oxidized and the other is being reduced, we can say that this can be safely called a redox reaction. Okay, the same can be done for the first equation that we did, which was also a redox reaction, because one element was gaining oxygen, meaning it was oxidized, and one element was losing oxygen, which means it was reduced. As for the second equation, this is also a redox reaction because this is also happening simultaneously. I would want you to remember that they are both processes, and reduction does not mean that the element is like it's reducing in quantity. It does not mean that. It just means that it's losing something, and that something is one of these things. Okay, like I have told you earlier, right? So that's for today, everyone. So we have done altogether 3 examples, and there's a lot more to come tomorrow. Tomorrow we are going to be discussing the loss of electron and the increase in oxidation state and oxidation numbers. So if you do not understand any of this, their comment section is open to you. So I would really recommend you drop your thoughts into that as well. Until then, I will see you in the next video. Bye bye.